Hello viewers, welcome to my channel Learning with Khatak. Hopefully you people have enjoyed the last two parts where we have performed univariate analysis and bivariate analysis uh, of the heart disease patient data sets. Our goal or aim is to build a models to input a patient data and then to predict whether the patients have a heart disease or not. What we have covered so far, uh, we have import our datasets of heart disease patient, and then we describe our datasets by looking into its features, number of records in the datasets, what are the records, what are the features, what are the target variables, what are the values of the target variables, and then performing the univariate analysis by looking the target variables, how many records are associated with the target variables. That means how many patients have a heart disease problem and how many problems have no heart disease. And then we look at the type of or features, data types or features, data types of columns, and then null values inside the data sets. Luckily we have no columns having null values. And then we covers the bivariate analysis, where we look the pairwise correlations of each features with the target variables. So, what we have done in the bivariate analysis, if we revise the part 2 before moving to the part 3, where we are going to conduct the multivariate analysis on the patient data sets. So, look at the uh, bivariate analysis. What we have done so far in the bivariate analysis, since we have a small data set having a 303 records, we compute the standard correlation coefficient, coefficients between every pair of attributes. We simply compute the correlation by using the dot core method of the data frames. And then if you look at these values, okay, the target variable is target, so we should check how each attributes correlate with the target variables. The actual data is the correlation data is that if you look at this data, from this data we can conclude the correlation coefficient range from -1 to +1. When it is +1, this signifies that there is a strong positive correlation. So we can see that there is no variable which has a strong positive correlation with the target. If we look at all the values of all the variables, uh, there is no variables which has a strong positive correlation with the target variables. When it is close to -1, when it is close to -1 means it means that there is a strong negative correlation. So we can see that there is no variables which has a strong negative correlations with the target variables. When it is close to 0, it means that there is no correlations. So there is no correlation between target and FBS, because this is very close to 0. We can see that if we look at the values, we can see that CP and thalage variables are mildly positively correlated with the target variable. So we will analyze we analyzed the interaction between these features and target variables like that. If you look at this, we first observe that CP stand for chest pain type. We will check here. We check number of unique values in CP variables, that is 4, and then there are 4 unique values in CP variables. Hence, it is a categoricals. And then we look at the frequency distribution. This is the frequency distribution. It can be seen that CP is categorical variables and it contains 4 type of values, that is 0, 1, 2 and 3. And then we visualize the frequency distribution. This is the frequency distribution with respect to the frequency distribution of target with respect to CP. And This is basically, if you look at this, CP variables contains 4 integer values 0, 1, 2, and 3. Target variables contain 2 integers 0 and 1s. 1 means presence of patients, presence of heart disease, 0 absence of heart disease. So the above analysis gives target variable values categorized into presence of and absence of heart disease and group CP variables. And then we will visualize simply here in this case. Okay, yes, the visualization is performed here. This is the visualization. uh, in case of interpretation of these visualizations, we can see that the value of target variables are plotted with CP. Target variables contains 2 integer values, that is 0 and 1s. If you look at this, yes, okay, this is the visualizations. Okay, and you people can also perform same type of frequency distribution and visualizations for tonnage and for rest of the variables by simply plotting, by simply replacing the CP variables with your respective interested correlations. So at the end, we conclude the bivariate analysis. Bivariate analysis, that there is no variables which has strong positives correlations with the target values. If we look at again at this, there is no variable which has strong positive correlation with the target variable. There is no variable which has a strong negative correlations with the target variables. There is no correlation between target and FBS. The CP and tonnage variables are madly positives correlated with target variables. We can see that tonnage variable is slightly negatively skewed. The people suffering from heart disease, and as we discussed in the last part about these. So now we are going to perform the multivariate analysis. That how to perform multivariate analysis. What does it mean by actually the multivariate analysis? Okay, multivariate analysis are performed to discover patterns and relationship in the data sets. Very important part, a part of ADE, exploratory data analysis, is to discover patterns and relationship between variables in the data sets. We will use heat map and pair plot to discover the patterns and relationship in the data sets. For example, if we look at the heat map, this is the, it will take some times. This is the heat map. This is the heat map. Okay, if we interpret this heat map, how to interpret this heat map? If we look at the x-axis age, chest pain, cold, CP, etc. All the features are listed in the x-axis. Similarly, all the features are listed at the y-axis also. Here, if we look at this, this is the target variable, which is 1, 1, 1, and 1. So this is the target variables, and rest of the variables are dependent variables. Sorry, independent variables, and this is the dependent variable, which means target is dependent on these. How much dependence? We can conclude its dependency from the correlation values, that how this is correlated with these values. So from here, if you look at this, target and CP variables are mildly positives, correlated correlation coefficient 0.43. If we look at the CP, so this is the CP 0.43. So it means target variables and the CP, target variables and ones, and this is 0.43. They both are mildly positive correlated. In the same way, target and TALH variables are also mildly positive correlated, because correlation coefficient, if coefficient is 4.2, 4.2 is near to 1. First, The value of CP correlation coefficient, that is 4.3, is near to 1 if we compare all the values, all the correlation values of the other variables. So CP is positively correlated, thalage is positive correlated. Target and slope variables are weakly positive. If we look at the slope, that is 0.35. 0.35 is have a relations, but weakly positively correlated, because CP has 0.43, thalage is 0.42, and slope is 0.35. Similarly, target and if you look at the another value, exchange minus 443, target and x variables are mildly negatively correlated. Correlation coefficient is minus 0.44. If you look at the, so if you look at the shapes, color, this color indicates positively correlation, this indicate positively correlation, and this indicates mildly negatively correlated. Similarly, if we look at the old P curve, same color, mildly correlated, again mildly negatively correlated. Similarly, if we look at the CA, if we look at the CA, this is minus 0.39, again negatively, weakly negatively correlated. And at the same way, if we look at the third one, 0.43, also weakly negatively correlated with this target variable 1. So this is basically the interpretation of heat map, that how a feature is correlated with the target variables. Close to the value of target variables mean positively correlated, away from the target variables means negatively correlated or weakly negatively correlated. So this is basically the interpretation of heat map. Now we want to analyze individual features with respect to target variables. So for this, I just first want to know about the target variables, that what is my what is my target variables and how many records are associated with. So again, uh, so if you look at this target, first analyze the target variables. 165 patients associated with heart problem, and 138 have no heart problem, and 165 patients have heart problems. So if we look at the distribution, this is the simple distribution. And if I want to know the percentage, if I want to find the percentage, that how many percent of patients have heart problem, and how many patients of problem and how many patients have no heart problems. If I run this code, look at this percentage of patients without heart problems, 45 points, and percentage of patients with heart problems is 54.62. So I just display this data from target temp 0. I just declare an array, and then I took the data from the, if we look at this, the data is string round, and then we simply display the percentage of the data. So now we will analyze 6 CP, FBS, REST, ECG, exchange, slope, CA, and thal features, because they are mildly positively correlated with the target variables. So we want to look and analyze these features, that's how they are correlated, and up to what extent they are correlated with the. So first I'm going to okay, that is, if I run this code, look at this, 0 and 1, and then we notice that as expected, the 6 features has 2 unique features, obviously 1 and 0, male and female. And then if you use a box plot to show this, So target means 0 and 1. 0 means female. How many females are heart patients and how many males are heart patients? Okay. Similarly, if we want to, from here, we notice that females are more likely to have heart problems than males. Similarly, if we want to analyze the chest pain, so for this after 6, we notice this female are more likely to have heart problems than females. Similarly, if we want to analyze the chest pain, obviously 4 values are there: 0, 1, 2 and 3, and then is expected the CP features have values from 0 and 3. If we run this code, if you look at this, then CP values mean 0, 1, 2 and 3. So if we want to interpret this, how to interpret these values? Let me show one things that interpretation of okay, wait just a minute to target. This is my target. Okay, let's wait to compile the code. Okay. Analyzing the FBS features, just to describe the FBF features, that is statistical measure, and then the unique values 0 and 1, and if we plot, this is basically the plot with respect to targets, nothing extraordinary. And then if you want analyze the yes, restrict. Okay, if we can show this, 3 unique values are here, and this, if we analyze the SNS plot, and this is the SNS plot of target variables. And similarly, we realize that people with rest think I and 0 are much more likely to have a heart disease problem. 0, 0 and 1 have much more likely to have a heart disease problem with respect to restic 2. Similarly, if we want to analyze the exchange, okay, if we want to the exchange, then two values, unique values having, if we look at the plot, okay, so it means people with exchange 1, that is exercise include angina, are much less likely to have a heart problem as compared to 1. So similarly, we can analyze the slope features. Look at this, 3 unique values, and if we want to SNS bar plot, then simply by looking at this, so here we can observe from this plot, okay, we observe that slope having 2 causes heart pain much more than slope 0 and 1. Similarly, if you want to analyze the CA chest, okay, sorry, numbers of major vessels 0 3 correlated, obviously unique values in the, just to know about the unique values of CA, there are 5 unique values, 0, 2, 1, 3 and 4. So if we want to the SNS bar plot, this is the bar plot. And yes, let me one thing more. This is, yes, now this is CA4, his astonishingly large number of heart patients. If it is clear from the graph that if CA4 with CA4 values more likely to be the heart patients. In the same way, you can analyze the third features, and these are the unique values. Okay, and then if we want to plot, then this is the plot. If I plot this like that, okay, okay, you can see like that the rate of increasing heart problem with respect to TAL. So this is the multivariate analysis. In multivariate analysis, nothing is important. One thing is most important in multivariate analysis, that we have looked in the heat map interpretations. That's how these are correlated with each others, and how we will how different features are correlated. If we look at the heat map, yes, this is the heat map. Basically, important thing is how different features are correlated with the target variables. So uh, if we look at the heat map values, target and CP are mildly positive correlated, having a correlation coefficient 0.43s. So from multivariate analysis, we came to know that three of our features, that is CP, thalage, and slopes, are mildly positive correlated with the target variables. They are strongly dependent. The target variable is strongly dependent on these three, that is CP, thalage, and slope. While the target variable have less dependency on CA, exange, and old peak. So this is the multivariate analysis here. We have completed multivariate analysis. In our next part, what we will cover, that is, okay, important part is part number 4. There we will divide our basic data sets and train test splitter, and then we will fitting our model. We will use a logistic regression model, and then accuracy will be checked, and then confusion matrix and classification report will be printed, that how our model is accurate. And then we will obviously compare the first model with the Navy Bias, that how Navy Bias perform on the same data sets, having different parameters. So for time being, thank you very much. Wait for the part 2, where we will start developing our model by splitting our data set into train and test split. Thank you very much.